The experiment is to analyze the tracking of currents on a conducting plane. We have connected a conducting plane to the emission reference source and we have set the frequency of the source at 10 MHz intervals. Hence 10 MHz interval signals are being generated up to few gigahertz. The signal is being fed to a slot. A slot is made in a conducting copper plane. This is simulating a narrow opening in a bigger enclosure. We are hypothetically simulating a small opening or a small window or a small crevice inside a big shielded enclosure, and we are trying to measure the behavior of the opening using the present setup. We connected a low sensitivity M3 probe to the EMC analyzer using the SMA cable provided, and you observe what happens. The moment we bring the probe closer to the conducting plane, there is a signal being observable on the CRO. Now we observe as we make the probe perpendicular to the flow of the current, there is very less signal being induced in the probe. But when the signal is flowing parallel to the probe, the signal is being induced. So this probe can be used to find out the direction of current flow in a conducting plane. Right? Now we observe as we move the probe across the width of the slot. The moment we are exactly on the slot, the signal induced in the probe is maximum. As we cross the slot, the signal level reduces. Hence, this slot is the major radiating component in a conducting plane. Hence, we need to watch out for small, narrow openings, narrow gaps in shielded enclosures. We need to seal them very thoroughly in order that they do not radiate. We see that thing again. You observe as I move the probe across the width of the slot. The moment the probe approaches and it is on top of the slot, the signal induced in the probe is maximum. The moment it crosses, the signal reduces. Now we observe as we move the probe along the conducting plane. As we move the probe along the conducting plane, the signal level increases as we near the source of the signal. Hence, we can find out the direction of the current flow in a conducting plane using a probe like this, and we can find out the source of the leakage in the conducting plane and can find out and account for small openings in a conducting plane and analyze the tracking of currents in a conducting plane.